All right, so for this week lab, especially part 3 right here, right? What we're gonna do is that we're gonna read and follow the instruction. I mean, follow the instruction for Mars from this link right here. If you click on this link right here, it's gonna take us to a Colab page where we can uh, basically get the data from the web and plot the position of Mars, the right ascension and declination for Mars, and we kind of see the retrograde motion of Mars right there. And when we see the plot right there, we gonna figure out the period of retrograde motion, basically when it starts to move backward, and then when it's finished moving backward and start to move forward again. Okay, and for our lab right here, we're also going to do one for Mercury. So when we finish, when we work on Mars successfully, you click on this link right here to open another Colab node for Mercury. So basically, what we can be doing is that we're going to be copying when you successfully get do the work for Mars. You can just copy and paste them over and do the same thing for Mercury. Um, and the code is basically the same thing. You may have to make some minor adjustment, like maybe changing the title from Mercury to Mars, and then repeating the same procedures right here. And there's also this videos right here. If you forgot about retrograde motion, you can click on and watch on that right there, right? So if you give me 1 second, let me go out of this. If you click on the link right here, right, it'll take us to um, the Mars retrograde instruction right here. And you can see right here, I basically it's just explaining what I mentioned earlier. And the purpose of this is to plot Mars retrograde motion. Just copy and paste the code over to your notebook, especially the first 2 lines right here. So if you say this line right here, right, just highlight, do a Control C. Control C is to copy, and Control V is to paste. So just highlight, and on a Mac, it's going to be a command. Highlight that, Control C, copy it over. And I have my notebook here already, right? So if you don't have it, for example, and just do a Control V, just paste them over, and then go over here. The second line I also provided to us right here, right? So copy them and bring them over, for example, right here. So if you didn't have this right here, right, you can create um, a cell and paste them in right here, okay? And then when you paste them in, just run them. You see right there, right? Give me a second. It's going to take a little bit to run. And then see right here, right? Basically, what it's going to do is it's going to go to this website right here. And then, it's going to, you can manually go in here and look at the position of Mars or any other planet from this website right here. Basically, what it's going to do is that it's going to read this data directly into our Colab notebook. And you can see right here, right, it's found 4 table. And the table that we're interested in, and you look at this, right, is this table right here, and which is table 2. So when we read that, we can see that there's, I read it again. So give me 1 second. There's 4 table, right? And the one that we're interested in is a table 2. So over here, right, over here, if you scroll on this page right here, the instruction page that I provided in Canvas, I only give us the first 2 cell and the last one right there, right? The rest, I just put it in a picture JPEG format right here. So what you're gonna do is that after you copy and paste this first 2 one right here, just go over here and start typing it in. See right here, right? This right here, the table 2 file DF hat is exactly like this line right here. So just go in there and, like, for example, if I didn't have that, just type in DF hat like that right there, right? And then run it, and it's gonna create a data frame in our canvas, and it's going to output this right here. Basically, it's the same thing, kind of like this one right here. You see right there, right? So the code is provided in our instruction. All you have to do is just copy and paste the first 2 lines over and start typing it in exactly like this right here. Okay, all the way until the last cell right here. This cell, last cell right here, when we plotting using bokeh. And the last cell I also provided here. See right there, right? What was that? Yeah, so the last cell I also provided right here, right? So the last cell, you don't have to retype it because it's a bit long. Just copy it, Control C to copy, or Command C on the Mac, and bring it over. For example, on the way at the end right there, right? And then just paste them over. So let me delete this right here, for example, and just paste them over. These steps in between, you could have to type it in. One thing you also have to be careful also is that there's if you see indentation like this right here, right? Make sure that you, in your code, you also have indentation too. Otherwise, Python is indentation sensitive, right? So especially for the for loop like this, if you have it like this, for example, then it's going to give you an error. So make sure that the indentation is aligned right there. Okay, so let me continue back here. And then, so this one right here, read the data in. The table 2 is what we're interested in, right? You notice that the column number is not exactly neat right there, right? So what we want to do is that we want to change the column. See right here, right? The column heading to something that is more presentable. So so I changed it to, this one is year. See right here, right? Here's a month, here's a day, and here is the right ascension. Right ascension is basically go along left, right, like longitude on the first, and declination is up and down, north and south right there, right? So if I run this one right here, you notice that it's going to give us a table, a data frame with nice column heading that we can reference and use. Okay, and then you notice that also that in our data, right, the last row is not something that we want. So we're gonna drop that row right there, which is this next slide right here. See right there, it's 100. Now 100 index. So we're gonna drop that, and you notice that the tail is just gonna give us the last 5 data point in the table, right? And you see that the 100 row has been dropped. Okay. Now you also want to, and the next step right here, right? The position is in this kind of format, which if we plot, right, we're not going to be able to plot it using matplotlib or bokeh right there, because it has to be in some sort of a real number. Like for example, 1.4 hour or 1.6 hour, not 1 hour, minute and second like that. Right? So we're going to have to convert all of this format right here into number, and you can see right here, right? So this one right here, I'm taking this first example from here, and see right here, 1 hour, 39 minutes and 16 seconds. So I'm taking that this example right here, and you see that for Python, right, the index thing starts from 0. So this is position 0. This is position 1, 2 right there, right? So what we want to do is that we want to take the first 2 positions. Basically in Python, right, this one right here is a string right there, right? So we want to take the first 2 positions, which is 0, 1 right here, right? The first 2 positions. So this right here would pick the first 2 positions, and excluding the first 2 is the 0 and the first right there, right? 0 and first, right? Excluding the second. So this one right here is going to take the first 2 positions, convert it into the type float. Right, the float is basically a real number, like 1.34 or 1.45. We want to have it in the float format so that we can do math calculation later. And you can see right here, right? So if I run that, it's going to take this column right here. It's going to take this column right here. Right here, this column right here, right? And take the first 2 string characters and convert it to a type float, convert it to a real number, and store it in the variable. This one right here, we can name it right here, right? RA hour. So right ascension hour. And you notice that we have 1.0, right? So that this one right here, we're gonna do the same thing. Basically, we're gonna go into we're gonna take this position right here, this two number right here, and which is a minute right there, right? Which is a minute, and we're gonna put it into RA minute right there. So you notice that it's gonna be 0, 1, 2, and 3, right? So we're gonna go 3, 4, and then in Python, if you want to pick 3 and 4, right? You have to end it with the fifth right there. So you can see. So this one right here is gonna pick 3, 4. So it's gonna pick the RA minute, which is 39. See right there, right? 39. And then this last one is gonna be the same thing. It's gonna pick the second. Okay. And 16 right there. See right there, right? 16. So when we have all of this hour, minute, second, right? This one right here is converted into the whole thing into an hour, one number. So minute divided by 60, it's going to go into hour. And then if you have second, you have to divide by 3600 to go into hour. And we're going to store our result into a temp variable. This one here is just a temp variable so that we can save the final our final work into a list. And if we run that, see right there, right? So this one right here, 1 hour, 39 minutes, 16 seconds, the format that you've seen, for example, in here, in this table, or in our data frame right here, right, has now been converted into something that can be plottable, 1.65 hours right there. Okay? So this is essentially going to be our the X position, right ascension right there. Now we're going to work on the Y. Okay. And here is, I'm using the example, right, for the Y is the 5 degree, 50 arc per minute, and 19 arc per second right there. Okay. So so 5 degree, actually using this number right here, right? So we do the same thing like that. We'll take the degree. Right, here's the degree, which is the string position. That's a plus right here, right? So we start plus because declination can be positive if it go north of the equator, north of the celestial equator, and negative if it goes south of the celestial equator right there, right? So here, there's a plus right here, okay? So we're gonna take this from 1 and 2. Remember, right, in Python, if you read string 1 and 2 like that, right, you have to add the excluding third, the position right after that. So it's going to be, give me 1 second. It's going to be 1 and 2 right there. Okay. So this one right here converted to float. And this one right here, 0, 1, 2, 3, 4, 4, and 5 right here, right? It's going to take the out of the minute right here and convert it to float. And it's going to take this, the third one right here is going to take this position 7 to 9 right here. We could actually 7 and 8 right here, 37, right? And to convert it out of arc of a second to degree, you have to divide it by 3600. Arc of a minute, to convert it to degree, you have to divide it into 60 arc of a minute right here. By the way, make sure that you also have this forward slash right here. Okay, in your when you copy over, you can do something like this. Second, it's going to be a long line like this right here, right? And that should be okay. See, let me run this like this. Let me run this like that. It's going to convert this into 5.8 degree. But if you want to have multiple lines, for example, like this right here, right? If you run it like this, give me 1 second. It's going to give you an error because Python doesn't understand that you can, this is part of the same line right here, right? So if you want to do something like that, then you have to give a forward slash like this right here, which is going to give you the same thing. So you can write this as a whole line, or if you want, if it's too long and you want to continue on the next line, for example, like this, then make sure that you have a forward slash right there. Okay, either one would work. So now we have now that we have the RA, the right ascension, in the real number format, and we also have declination in the real number format. Now we can start plotting it. But before we go, right, I mentioned earlier that declination can be positive or negative if it's above the celestial equator, negative if it's below the celestial equator, goes down. Right there, right? So we have to take the sign into account right here. You see right here, right, for the ephemeris, you notice that there's a plus, 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 plus like this right here, right? Sometimes it can have a minus. So if it has a minus, then you're going to want to have minus number. If it's positive, then you're going to want to have a positive number, right? So this thing right here, just check the condition. See right here, right? It takes the first position, which is this guy right here, the sign, right? And then it's gonna go over the entire list one by one, and to check if it's a plus, then then you're gonna want to have plus one or 1.0. If it's if this thing right here is a negative, right here L, right? L, which means negative, then you can want to multiply that by -1 right here for negative number. And then over here, let me run this. Okay, so right there, right, because a plus, so our number is going to be +1. Now we're going to multiply that the sign right here to the deck convert. So make sure that we have the appropriate sign. Okay, and then once we have the appropriate sign right here, we can start plotting. You've seen some of this before already, like for example, in the Orion and Sirius blood plot, right? And so if you click on this, you see right here, right, this is title, this is the X label, Y label. So when you hit on that right there, right, it's going to give you a plot of the position of Mars right here. Okay, and then we want to invert the axis a little bit because by convention, we start from here and going from higher RA go to lower this way right here. So if you Google, for example, star chart, you will see the progression like this right here. So we want to keep the convention like that. Okay, so this is the plot of Mars position. You notice that it starts to move forward this way right here, right? But at this point right here, it starts to move backward. When you look at on the sky, it seems to be moving backward on the celestial sphere or celestial globe. And here it starts to move forward again, right there. Right? So this part right here is retrograde. Okay. Now I want us to find out the time, the period, the beginning and the end of the retrograde, the period of Mars retrograde motion right there, right? MATLAB would not be able to do that for you. So you have to use Poké right here, okay? And then this one right here is just take the year, month, and day in the data frame and put it in a nice format like this, so we can tell what time, what day it is, okay? And this last column right here is gonna plot it with interactive. Give me 1 second right there, right? With interactive. You see, right, because we have we put the description. Notice right here the description, there's a date description, and then we use the hover tool in Poké right there, right? So when you hover over a point, it will tell you which index number, what index it is, the I, the position, and the time right here. Okay, see right there, right, and right there, right. And then with here, you can also zoom in. For example, you want like that, you can reset it, and you can also zoom in. Give me 1 second. Let me click on this right here. Right, and so you can you can hover to them and find out the more or less the exact date that Mars start to go backward, and then the exact date when it's end going backward and start moving forward again. Okay. And you can see right here, right? You can reset it using Poké. So I like Poké a lot. Now, when you done this right here, right, and you figure it out for Mars, right? The next thing you're gonna do is you're gonna click on this link right here. Okay. You see right there, right? This link right here just provide you this two position right here. But what we read in this situation, instead of reading Mars, right, we're gonna read in Mercury. See right there, right? Mercury. So just copy and paste this over to your Mercury notebook. See right here, just run that, and then you notice that run that, it's gonna read in, it's reading in the data, okay, for Mercury, and that's right. And when you have this right here, you can just go back to Mars and go back to Mars. For example, this one right here, right? You can go back to Mars, and then just start copy and paste your the code over, like exactly the same. Copy and paste them over. For example, Control C, and then go over here, create a new node, Control V, right? And then boom, like that. Right now, you're reading data from Mercury. Okay, so and then repeat the same thing and find the period of retrograde motion for Mercury. Okay, so essentially this lab right here, right? Make sure that you follow the instruction in for Mars, and then after that, just do the repeat the same procedure for Mercury. I provided the code for the first two one right here. Make sure that you run, hit the run when you finish it. And sometimes when you have trouble right there, right, maybe you can do a runtime right here and just run all right there, right? And then, when all else fail, ask me a question, okay? I'm here to help you. So good luck with this lab. And, if you have any question or anything, just ask me, okay?